Hello there. Okay, welcome to chapter 11, which will be on deformation of solid. So for today we will look into the example. Okay, quite short chapter actually. We only have two examples to discuss in this chapter. All right, let us look into example 11.1. Okay, you have a thin steel wire, initially 1.5 meter long and has a diameter of 0.5 mm. Okay, is suspended from a rigid support, and then you have a mass of 3 kg is attached to the lower end of the wire. So over here they wanted to calculate the extension of the wire and then the energy stored in the wire, and you are provided with the value of the Young modulus for steel. Okay, so the information given, okay, mass suspended, okay, initial length, diameter, and also Young modulus. Okay, so based on the given information, we can calculate the cross-sectional area of the wire. Okay, so which will end up with 1.96 times 10 to the power of -7 meter square. Okay, and then the applied force. Okay, so we just determine the weight acting. Okay, mass is already given. We just calculate the weight acting. Okay, which will be in Newton, 29.4 Newton. Okay, and then by applying the Young modulus formula, okay, just replace in the value over here, and then we can determine the value of E, okay, which will be the extension or elongation, okay, which will end up with the final answer 1.13 times 10 to the power of -3 meter. Okay, and then to calculate the energy stored, we can use the equation of energy stored, okay, which will be half force times with the value of extension, which you already obtained from question A. Okay, so just replace in, so which will end up with the total amount of energy stored, which will be 0.0166 joule. Okay, next let us look into example 11.2. Okay, so this one you have a copper wire LM fused at one end, okay, M to an iron wire where MN as shown in figure below. Okay, so you have a copper wire and iron wire, okay, fused together, and then the copper wire has a length of 0.9 meter and cross-sectional area given as 0.9 times 10 to the power of -6 meter square, and then the iron has a length of 1.4 meter and cross-section area given as 1.3 times 10 to the power of -6 meter square. The compound wire is stretched and the total length increased by 0.01 meter. Okay, they wanted to determine the ratio of the extension of copper wire to the extension of iron wire, and then B, extension of each wire, and then C, applied force to the compound wire. Okay, so Young modulus for iron given, okay, and also for copper also given. Okay, so the given information, okay, initial length of copper, so we use subscript C and I lah. Okay, so C that means represents copper, I represents iron. Okay, and then over here we have E total extension. Okay, and then Young modulus for each copper and also for iron. Okay, so the equation for Young modulus, okay, given. So what we do is that we are going to determine the ratio of elongation. So we rearrange in terms of E. Okay, so since we are going to determine the ratio, okay, copper to iron, okay, so divide and then replace the value of copper to the ratio of iron lah over here. Okay, so since we apply same amount of force across these two, okay, so that means force across copper and iron, which will be equal, which will be a constant force F, okay, which can be cancelled off, rearrange, okay, in terms of ratio, replace in all the value, and the final answer of the ratio copper to iron, you will get a ratio of 1.5. Okay, so since it is a ratio, we don't have any unit. Okay, we just have a magnitude only. Okay, for question B, total extension is given. Okay, total will be addition of the elongation of copper and also iron. Okay, so from the ratio we can determine the elongation for copper, which will be 1.5 times elongation of the iron. Okay, so what you can do is that we can replace in, okay, to determine the elongation of iron. Okay, once you have done that, you can determine the extension of the copper wire. Okay, and then to determine the applied force, okay, we can use Young modulus and then replace in either one value lah. Okay, so over here solution they are using copper, or you can also even use iron. Okay, so just replace in the value to obtain the final answer. The force will be 780 Newton. Okay, that's all for this chapter lah. Okay, have a nice day.